Hi guys, I'm going to be solving question number 2 on your homework. Question number 2 on the homework. So this is not a free fall, or it's not going on the horizontal, but that is actually moving in the incline. So in part A, they're asking for the free body diagram. And I hope you guys are comfortable with that now. So you have always gravity going straight down, mg, and there is no friction but the air resistance this time. While before the air resistance you have a normal force, and this normal force is going to be perpendicular to the surface, Fn. And then you also have air resistance, so that is going to be going against the movement, so that is going to be drag force. Alright, and you don't need to show that, but the angle in between this drag force and normal is supposed to be 90 degrees because one is the surface, the other is perpendicular to the surface. So that is your free body diagram. In part B, they're asking for the differential equation, but they don't ask you. They don't want you to solve it. So all they ask is write down the differential equation to find the velocity as a function of time. So in this case, we are actually talking about. So if you don't know what we are doing on an incline, you need to watch the lecture for an incline. Like motion on an incline plate. So you basically have x and y components, or x and y axes, as like this. So normally you don't work on the free body diagram, but I just don't want to have an extra space, so I just work on this. So in this case, they give you angle theta right here. So if this is angle theta, then I told you that this angle is supposed to be theta. And if this is angle theta, so this is your y-axis and this is your x-axis this time. So what does that mean? You need to find the components of this mg, because Fn and Ft, they are on the axes right now. The only force that is not on the axis is mg. So you need to find the components of that guy, and that is going to be given as this guy. This is going to be the y component, and this is going to be mg times, since this is, as you can see, this is the adjacent side, and the angle times adjacent will give you the cosine. So that is supposed to be mg times cosine theta. And if you extend this, you will see that it's going there. And your x component for this vector is going to be right here, and this is going to be the opposite of this guy. So mg is your hypotenuse, and then you have this theta, so it's going to be mg sine theta. So you basically found the components of x and y. So there's no friction, so we don't need to worry about what's happening on the vertical axis. All we need to worry about is what's happening on the x-axis. Alright, so object is basically accelerating in this direction. Right? And I can choose this direction as positive. Then I'm going to have mg sine theta going downward, but Fd is going to go against that motion. Then I'm going to have Fd going negative. But Fd is given to me as BV. Alright, so mg sine theta minus BV will be equal to what? Mass times acceleration. So the sine of acceleration and sine of mg sine theta is going to be the same because they're going in the same direction. So I choose this guy as positive. This is going to be positive. and BV is going against that mg sine theta. Alright, so that is not the differential equation yet, because yes, I have V right here, but I don't have this A in terms of V. So all I need to do is mg sine theta minus BV m dV over dt. That's all I need to do. I replace this acceleration with dV over dt, so that is going to be the solution, or that is going to be the answer for part B. And in part C, they are asking for terminal velocity. And again, let's remember the meaning of terminal velocity. Terminal velocity is when those two forces, this mg sine theta and this drag force, when they are equal to one another, and or in the other way of saying acceleration is 0. So if this is 0, then mg sine theta minus bv equals 0. Then that means mg sine theta equals bv. But this is a special case. We call it terminal velocity, so we show it as vt. Then I just need to solve this for vt, and my vt is mg sine theta divided by b. So far, we got 9 points. Alright, that's unbelievable, but this is 3 points, this is 4 points, and this is 2 points. So far, that is, out of 15 points, you got 9 points already. Alright, now they are asking to difficult part. So in part D, they're asking for, before I actually move to part D, let's talk about acceleration graph of it, because it is going to be easier to solve it right now. Then I will just use the entire board for part D. So in E, they're asking for the acceleration of the object. So are you going to start with a maximum acceleration or minimum acceleration? That's what we need to think about. And if you think about it, at the beginning there is no drag force, so I'm going to start with the maximum acceleration. So in this case, what's my maximum acceleration? Let's say there is no force, there is no FD. mg sine theta equals ma. M's will cancel out, so my acceleration is g sine theta. So I start with the maximum g sine theta acceleration. As time goes on, what's happening? Drag force is building up more and more and more, and at the end, this guy becomes equal to this. That means your acceleration is becoming 0. And since this is happening like over time, and as it increases, that is also increasing. So that's not going to be a linear thing, that's going to be an exponential thing. So that is going to give you something like this. Alright, so that is basically my acceleration time graph, and that's the last part. Alright, now let's solve for D. So now what we need to do is we are going to use this differential equation to find velocity as a function of time. And let's see how we do it. Again, it's going to be the exact same steps. This time I'm going to have a little bit more like stuff to worry about over here. But the results are going to be the same. So let's see what we have. This is part D. mg sine theta minus bv equals mdv over dt. So again, what were we saying? We are trying to get rid of this t. So we put dt one side and then take all of the v's, any function or any variable that includes v under like dv. So to be able to do so, I had told you that you take the entire function and then you switch it with this dt. Then in this case, what's going to happen, dt is equal to m dv divided by mg sine theta minus bv. And over here, you can get rid of this m, so you can just divide everything by 1 over m. So what are you going to get? dt over m will be equal to dv divided by mg sine theta minus bv. And now, what is the next step over here? Determining the boundaries. So what are my boundaries? What is my initial time? My initial time is 0. And what is my velocity at that point? If you read the question, you will see that object starts from rest. So at time equals 0, my velocity is also 0. And what am I trying to do? I'm trying to go from 0 to any time t, and I'm going to go from 0 to any velocity v. And I'll just keep this as v and t because that's what we need to do. We, like in the exam, we should not have that as a t prime or v prime. We need to keep it as t and v, representing any time and any velocity. Alright, so again, mass is a constant here, so that can come out. So I don't need to worry about that. So 1 over m is 0t dt, and then 0v dv divided by mg sine theta minus bv. So now what do we have? 1 over m, just a constant, dt, t to 0. So that means the integral of this guy is just function t, and then you go upper boundary, lower boundary, so t minus 0 is just t. So on the left side, this part is going to give me just t, so t times 1 over m will give me t over m. And on the right side, let me write this a little bit lower so I can actually solve this over here. So t over m, that's what we have from here. And what am I going to do over here this time? Again, I have a complex function, so what should I do? I should replace this guy with u. So my u will be what? mg sine theta minus bv. But then my new function is what? dv over u. And it doesn't work, so I need to replace this dv with du. And how am I going to do this? I just take the derivative of this u function with respect to v function, and that is going to give me the relationship in between them. So if you take the derivative of u function, which is mg sine theta minus bv with respect to v, mg sine theta, this is a constant. So derivative of a constant is 0, so I'm not going to get anything from there. And what is the derivative of negative b times v with respect to v? So you will just get the coefficient, which is negative b. Then what is my dv function in terms of du? So if you just replace those two, switch dv and negative b, it's going to become negative du divided by b, right? So you just switch negative b and v, and it will become du over negative b equals dv. So that is basically going to be the substitution that we are going to make. So T over M is what we have on the left side. And now I have substituted dv with negative du over b. And then I have substituted this, all of this function with u. And since it's in the denominator, it's going to be 1 over u. And now this negative b is also a constant, so I can get rid of this guy. And I still have this integral because I did not take the integral yet. So this negative b can go to the other side. How is it going to go? So that's in the denominator, so it's going to go to the top. I have this negative, and I'll just put it in the front. So negative bt over m is going to go from 0 to v du divided by u. And now I have that nice function this time, du over u. So I can take the integral of that function. Negative bt over m is going to be equal to integral of du over u is ln u. But what is my u this time? I am going to be going back and replacing it with the original. It is a little bit long, but it's mg sine theta. There's no v right there, minus bv. And what are my boundaries? 0 and any velocity v. And let me write this one down right here. Negative bt over m. We have nothing new right there. So I have this function, and what was the rule for replacing upper and lower boundaries? Place the upper boundary minus place the lower boundary. So ln mg sine theta minus b. So I'm going to replace this v with the upper boundary, which is the same thing. Remember, we were using prime, but you don't need to, actually you should not on the actual exam. So I just replace this v with upper boundary, which is also bv. This is upper boundary first, then minus lower boundary. What's my lower boundary? 0, so I'm going to substitute this v, because that's my only variable, with 0. So ln mg sine theta minus b times v, which is b times 0. And then I close the parentheses. And now, again, let's remember ln a minus ln b can be written as ln a over b. So I'm going to continue with that over there. So negative bt over m is going to be equal what? I have this ln right there. So ln upper boundary first minus lower boundary, which is upper divided by lower. So on the top it's the same thing. It's mg sine theta minus bv. That stays as it is. And the lower boundary, same thing, but this negative b times 0 will be gone. So I'm just going to have mg sine theta on the bottom. And now I have ln, and I need to get rid of this ln, and I got rid of the derivatives, so all I need to do is get rid of this ln now. And what was the way to get rid of this ln? Again, use e as a base and use the others as a power. So once you do this, what's going to happen? This e and this ln will cancel out. Let me go continue with the blue. And there's nothing to cancel out over here, so that is just going to stay as a power of e. So it's e to the power negative b t over m. And they cancel out. On the right side, I'm just going to have mg sine theta minus bv divided by mg sine theta. So now I'm trying to solve this for v. So I need to get rid of that mg sine theta in the denominator. So multiply everything with mg sine theta. So it's going to be mg sine theta times e to the power negative bt over m. And I got rid of this, and I have another mg sine theta minus bv. So now I need to get rid of that mg sine theta. To be able to do so, I need to subtract mg sine theta from both sides. So mg sine theta e to the power negative bt over m minus, let me write this a little bit higher, bt over m minus mg sine theta will become, that got rid, like we subtract mg sine theta, so I cancel that out, is equal to negative bv. And next step is going to be multiplying everything with negative, just to get rid of this negative. Then that will become positive, that will become negative, so I'm just going to bring it to the front. So mg sine theta minus mg sine theta e to the power negative k, not k, b t over m, and that's equal to b v. And my last step, like final last step, is going to be dividing everything with b. So my v as a function of time will become mg sine theta. And actually, let's take everything into mg sine theta function, or mg sine theta parenthesis. Mg sine theta is going to become 1 right here, and minus e to the power negative b t over m. And we had divided everything y by b, so that will go right here. So this is my velocity as a function of time. And that is going to be the solution for question number 2 in your homework. So as you can see, we are doing the same thing again and again. So you just try to get used to those steps, and then please try those questions on your own as well, and see where you're messing up, and then go back and look at it again. And at the end, you will be able to solve it, but you guys need to practice. All right, thank you.